Okay, hey dual enrollment. Sorry I can't be there, but this is the next best thing. Okay, so I'm going to redo some of the questions from 4.5 that we did last week. So if you have these down, you can skip on ahead and then get to where we left off in class. Those of you that were absent, this will give you a way to catch up to where you should be. Okay, so we're looking at exponential equations. Just like that sounds, it's an equation that contains an exponent, which an exponential has the variable in the exponent. Remember, we looked at those before Thanksgiving break. So, and just to remember and refresh, we have that b, x, and y are real numbers with b greater than 0, b not equal to 1, then b to the x is equal to b to the y, implies that x is equal to y. Remember, the b's are the same, so of course the x has to be equal to the y. Okay, so let's look at a couple of examples. Okay, so the first one is 4 to the 2x minus 3 power is equal to 64. So the best way that you do this first is we can rewrite 64 as 4 to some power. In fact, it's 4 cubed. So we can rewrite that left side of 4 to the 2x minus 3 power. Well, 64 can be written as 4 cubed. Now we have two exponentials, or two exponents with the same base of 4. So thus, 2x minus 3 is equal to 3. Now we're left with a linear equation just like we had in Algebra 1 and 2 that we can solve for x by. So we add 3 to both sides and we get 2x is equal to 6. And then dividing by 2, we get that x is equal to 3. Okay, let's go over to 3 since it's the same setup. So we have 5 to the 2x plus 2 is equal to 625. Remember, we can rewrite 625 as 5 to some power. In fact, it's 5 to the 4th power. So 5 to the 2x plus 2. So we have 2x plus 2 equal to 4. Subtracting 2 from both sides, 2x is equal to 2, so x is equal to 1. So that's how both of those worked. What did we do? Well, we rewrote the constant number as the same base as the other side raised to some power. Okay, as long as we can do that, we can work them all the same way. We get the same base and we set the exponents equal to each other. So looking at 2 and 4, we see we have two different exponentials on both sides, but one has a power of 27 and one has a power of 1/3 looking at number 2. Well, that's okay, we can do this because 27 is the same as 3 cubed. So we have 3 to the 3rd power, and then all of that is being raised to the 2w plus 5. So I just rewrote 27 as 3 to some power. Okay, I can do the same thing with 1/3. I can rewrite that as 3 to the negative 1 power. Again, it's still raised to the 2 minus 5w. Well, what do we know about exponents? Our exponent rules from like the first week of school tell us that we have the power of a power, we can multiply them together. So we have 3 to the 3 times 2w plus 5 is equal to 3 to the negative 1 times 2 minus 5w. So we have two exponentials with the same base, so we can set the exponents equal to each other. Of 3 times 2w plus 5 equal to negative 1 times 2 minus 5w. So we have 6w plus 15 is equal to negative 2 plus 5w. And then you can solve for w like you would normally, and we would get that w is equal to negative 17. So w is equal to negative 17. My negative sign is disappearing. So negative 17. Let's just rewrite. That's better. So number 4, I want you to try on your own. Do the same thing as we've done in 1, 2, and 3 and see what you get. You can pause the video now and work it on your own. Okay, so if you set this one and work it, you would get 7 to the 2x minus 3 is equal to 7 to the negative 2 times x plus 1. So 2x minus 3 is equal to negative 2 times x plus 1. So 2x minus 3 is equal to negative 2x minus 2. So you add 2x to both sides. 4x is equal, adding the 3 to both sides, to 1. So x is equal to 1/4.